Good morning, everyone. We are so excited for all that we have lined up today. I am Christy Morganson, co-director of the Space Policy and Research Center, aka SPARC, at the University of Washington. I'm also professor and chair of the William E. Boeing Department of Aeronautics and Astronautics and director of the Washington NASA Space Grant Consortium. I am joined by my colleague, the other co-director of SPARC, Sadia Pekkanen, who is a professor in the Henry M. Jackson School of International Studies. Before we move on with anything else, even though we are virtual for many of you, we want to acknowledge that we stand on the lands of the Coast Salish peoples, whose ancestors have resided here since time immemorial. Many Indigenous peoples thrive in this space, alive and strong. We also want to note that we, SPARC, and our associated groups are intentionally working on dialogue and actions that respectfully honor, learn from, support, and engage our Native populations. Our first panel will specifically address this goal, and we ask that you listen to that panel, learn, and consider actions that we can all take. We are also thrilled to count on the support of Salal Credit Union again this year. Salal is looking into the best ways it can support the aerospace ecosystem in Washington State. Visit their sponsor booth to learn more about their efforts and connection to the UW and the area. I would like to give a shout out to AeroVironment and our alumnus Dane Hoff for their support as well. So also stop by their sponsor booth in that same area. We are excited to explore many areas of energy and power, design, and policy issues surrounding our future in space. And this year we've added a tutorial speaker for each panel, giving a general overview of the current conditions or state of the art for each session topic. So we're excited to see those. We're getting the hang of these virtual platforms, and while we're looking forward to getting back fully in person, we are able to reach a really extensive audience and group of speakers in this online format. While we do miss the in-person networking, I would encourage you all to look around the Whova platform and take advantage of the connections we can make virtually. Please enjoy the day. Network with each other, ask questions. The Q&A is there in each session for you to submit the questions that matter most to you. You can upvote the questions of others. And if we don't get around to questions during a session live, then the panelists may be able to stick around to address some of those questions afterwards through the Q&A. So again, chat with each other, connect. Sadia and I will be here throughout the day, guiding us through the sessions, and we can't wait to get into each one. So Sadia, I'll pass it on to you now.
Thank you so much, Christy. Also a very warm welcome from me. I'm Sadia Pekkanen, co-director, as Christy mentioned, of SPARC. I am the Job and Gertrude Tamaki Endowed Professor at the Henry M. Jackson School of International Studies and also adjunct professor at the School of Law. I specialize in the commercial, legal, and security policies shaping outer space activities. Thank you for being here with us today. We are very excited for what is coming up, which is very much in line with SPARC's mission of bringing together STEM and policy. We will get a very good foundation on how we plan to power our activities in space, from propulsion to habitation, but we will also be taking a look at how we design the system of space activities to create the social, environmental, and workforce benefits we need here on Earth. I can't wait for the rich discussions that are coming up. And now I have the great pleasure to introduce our keynote speaker, Dr. Asha Balakrishnan, who will be speaking on sustainably developing and powering the space ecosystem. She is uniquely qualified to make these remarks, and I want to give you a brief background to her work. She is an assistant director at the Science and Technology Policy Institute, a federally funded research and development center that provides rigorous and objective analysis of science and technology policy issues for the White House Office of Science and Technology Policy. She brings engineering expertise to the areas of space policy, program evaluation, advanced manufacturing, and STEM education and workforce training. She is very well versed in space situational awareness, orbital debris issues, space traffic management, and small satellite technologies. From 2019 to 2020, she was an ASME Congressional Science and Engineering Fellow on a one-year leave of absence from STIPI, where she worked for the majority staff of the House Science, Space and Technology Committee, Subcommittee on Space and Aeronautics. Asha, welcome. Dr. Balakrishnan will be taking a few questions after her talk, so please write the questions you would like her to address in the Q&A for this session in Whova, and Amy Sprague of Spark will be monitoring those questions. Over to you, Asha, and welcome again. Thank you.
Thank you so much for inviting me to this symposium. I'm very excited to be here. I am honored to be asked, and I'm looking forward to delivering these remarks and listening and trying to answer your questions at the end. So from looking at the agenda, it looks like today has a terrific venue to bring thought leaders together in academia and industry, as from the Pacific Northwest, where so much of the innovation takes place in the aerospace sector, and discuss this important topic of powering space. I'm going to play on the words powering a little bit and discuss sustainably developing and powering the space economy. I'd like to start by discussing what aspect of science and technology policy I've worked on or I work on currently. The Science and Technology Policy Institute, as Sadia mentioned, is an FFRDC, a federally funded research and development center. And this particular one supports the Office of Science and Technology Policy of the White House. There are some 42 or 43 FFRDCs around the country. And they support mostly executive branch agencies. We're the only one that supports the White House offices, the EOP, the Executive Office of the President. And our FFRDC was actually established by Congress in the early 90s because of the threat of competitiveness with Japan. So this was something that's a little surprising now because we're in very different times now, but there was a belief that the White House needed objective advice on science and technology issues, and that having an FFRDC could help them provide that advice without sort of any varnishing of the actual objectivity. So really providing the understanding of the landscape so that the policymakers can make their decisions. So FFRDCs are also unique because we're not government employees. We can be independent and objective about our analysis, and we work on issues to support the US government full sail. In the case of STIPI, the rigorous and objective analysis that we do is in the support of the Office of Science and Technology Policy, but we also do work for other government agencies, including NASA, Department of Energy, National Science Foundation, NIST, many other S&T agencies around the government. OSTP is sort of uniquely positioned, for those of you who might not be familiar with it, as an interagency, as a coordinator of the interagency. There are several science and technology issues that require coordination across the government. Different agencies kind of touch different parts of the elephant, but when you put it all together, there is OSTP in certain really critical topics, are trying to pull it all together and make sure that the agencies are coordinating and collaborating so that there are, there's sort of one government working together. And so many of these difficult problems are at the intersection of technology and policy. And not all problems have a technology solution, and not all problems have a policy solution. Sometimes it's a combination, sometimes it's one, sometimes it's the other. So our organization tries to really understand both sides and offer the solutions that could work going forward. As many of you know, there has been a revitalization in the space economy over the past several years. With the commoditization of hardware that enables small satellites or CubeSats to the manufacturing processes that allow for hundreds of satellites to be mass produced, to the lowering launch costs, the space sector is vibrant and changing. Up until about 10 years ago, most of that activity was limited to communications and remote sensing satellites. There has been, of course, military satellites for many, many years, and other activities that the government might have engaged in. But now in 2020, there are many more activities and innovations taking place in space. They are more capable and lower cost geostationary satellites. There is improved capabilities from small satellites, from lower cost sensors on board to more satellites out there to improve revisit rates. There are more capable launch vehicles, increasing launch activity and more choices. And finally, there are increased telecom services, increased resolution of commercial available imagery, and new satellite services altogether. One example of a new satellite service and some of the new activities that are happening in space is a life extension vehicle. So the Northrop Grumman recently demonstrated life extension capabilities to a geostationary satellite owned by Intelsat, and this was for the first time in February 2020. The Intelsat satellite was operational and healthy, but its fuel had been depleted. And after you run out of fuel, there's no kind of AAA to tow you out of the way. So once the fuel runs out, the satellite's done. It's just there. It's a dead body. Northrop demonstrated that their mission extension vehicle, MEV, could use its own thrusters and fuel supply to extend the lifespan of the Intelsat satellite, and it performed station keeping maneuvers and kept it in place in geostationary orbit. It's contracted, Northrop is contracted to provide the satellite 5 years of life extension services. And at that point, the MEV vehicle, the Northrop vehicle, is designed to undock from that particular satellite and move on to another one. It's going to move that satellite to a graveyard orbit where it won't produce debris, or well, it might, but it's not going to affect the other satellites. And then it's going to go on and provide life extension for another geostationary satellite. This is sort of amazing demonstration of what commercial is capable of doing, what the needs are in space these days, and how there's a very new and burgeoning service industry happening. So growth in space is really a reality. It's happening now. I did a study for OSTP on the use of commercial, or the forecasting how CubeSats and SmallSats may be used in Earth observations. This was maybe 6-7 years ago. And at the time, many of the commercial providers were saying, we're going to be there, we're going to be able to help, we're going to be able to provide commercial Earth observation data to the government to do certain things. It's going to be cheaper, it's going to be disaggregated, we're going to be able to get data that's more timely. It may not be at the same image quality that we have right now, but it's going to, the revisit rates, meaning the number of hours it takes to take another image over that field in a farmland to understand what's going on with my crops, is going to be much more frequent than it is right now. The government folks we talked to at the time didn't really believe it. They didn't think it was going to happen. They said, yeah, well, maybe it'll happen. I'm not sure we're going to be able to procure it. It's going to be really hard. We're going to still have to provide the satellites that we provide and fund those things. And I'll tell you that, it's 5, 6, 7 years later, and the small satellite industry is really taking off. It's a game changer. The pace of commercial launches of satellites, particularly these small sats, is very high, and it continues to grow. In 2019, there were about 500 satellites launched and about 1,300 satellites in 2020. At present, there are a total of about 5,000 active payloads on orbit, right? So thinking about it, I'm an engineer myself, so thinking about it as a control volume, as a system, there's a system out there. We're putting things in. Some things are active, some things are passive, some things are deorbiting and coming out of the system. So from that standpoint, there are the U.S. Space Command and the Combined Space Operations Center, they track about 24,000 objects in their catalog, and about 5,000 of them are active payloads. And this is what they can see, 10 centimeters or larger. Smaller objects that are not tracked or cannot be seen by radar optical telescopes are not as well understood or even known. While the number of active satellites is growing, mostly from commercial providers, the number of different actors and countries who are interested in becoming spacefaring nations is also growing. So on the policy side, there's just a lot of change happening. As many of you know, but I'm going to kind of review for you today, space is funded, managed, operated, regulated across many different parts of the US government. So let's start with the legislative side. There are 2 authorization committees, one on the House and one at the Senate side, and 2 appropriations committees as well. Now, that's just for NASA. Many of the agencies that have equities in space are across many different committees. But let's just talk about NASA. NASA has an authorizing committee in both chambers and appropriations committee. And without going into it too deeply, but understanding that this is part of the process, is that the authorizers outline what the agencies need to do in broad strokes. They authorize the agencies to go forth and have certain missions, stand up certain directorates, and execute the mission as stated in the executive branch charter for that agency. The appropriators tell them how much money they have to do it. And so there is a tension, obviously, and in many times, authorization happens by way of appropriation, where money actually, the appropriators say, this is how we want you to spend your money on this. And sometimes they're outlining things that maybe should fall in the lane of the people who are telling NASA what they should be doing, should do, and vice versa. So it's a very difficult situation to work out. And I think the equities, both on the House and the Senate side, with which agencies are doing space, is very different. And as a result, it's hard to pass legislation with respect to space. And the reason I'm bringing this up is because, in the US, we start with the legal side and the laws, and then it moves into the regulation and the policy side. And a lot of things flow in that direction, but a lot of things can be executed on the executive branch on the policy side without legislation. So in terms on the executive side, there is the National Space Council, which was reestablished after being dormant for a few administrations. It was reestablished in the previous administration, and it's getting its legs going right now in this administration. In fact, it was just announced that Vice President Harris will be chairing the first National Space Council meeting on December 1st at Goddard Space Flight Center in Maryland. So that's really exciting for the space community to see that the cadence is picking up, and that there's a commitment to working on really important space issues. There's also the Office of Science and Technology Policy, which in the Obama administration was sort of the point for the executive offices to do a lot of the space policy. The National Space Policy of 2010 came out of the OSTP, and they continue to do work at the interagency on space issues, anything from Earth observations, which has a lot of space equities in it, to orbital debris, to other topics that are of interest in the space community. There are also a number of agencies that are responsible for both funding space and operating in space. So NASA is the best known, with a large $23.3 billion budget, about $7 billion for science, $7 billion for exploration. And you can go read their budget request and see where all the money is going. There are other things NASA does, but their mission is really to lead and innovate a sustainable program of exploration with commercial and international partners to enable human expansion across the solar system and bring new knowledge and opportunities back to the Earth. Their mission is not necessarily to clean up space junk. It is not to operate certain things in space. So they have a very exploration focused mission. At the same time, in order to do their exploration, they have to understand some operations as well. The Department of Defense also has a large presence in space and is growing. Recently, with the Space Force being stood up and the DoD relying on satellites to do their mission, they are continuing to see space as a really important domain. And the DoD funds and operates several different satellites. It also buys commercial data from commercial satellite providers. And here we're starting to see a transition and a real push with commercial providers, companies, startups, collecting remote sensing data and trying to sell it to the US government as part of their portfolio of data that the US government needs to operate and to do the work that they do. There are also other agencies involved in space. In addition to NASA, there's NOAA, there's the US Geological Survey, there's the National Science Foundation. They're all procurers of and satellite owner operators. They launch, operate, and provide satellite or scientific and operational data to the research community and the public for things like weather and climate. I'm laying all this out for you to understand kind of the policy landscape and where technology fits in. So the development of new technologies in the forefront of things happens at NASA. the exploration missions, the missions that are looking at how to get more effective propulsion, which is kind of the topic of your conference, space nuclear power, how we're going to operate sustainably on the moon, how we're going to get transit times to Mars, back and forth quickly. Those are all things that are happening at the frontiers of S&T and are being invested in at NASA. At the same time, there's a whole new world of operations in space that's coming up. And right now, I feel like our legal framework, as well as our policy framework, is slow to respond to all of the different things that might be happening in space in the future. On the regulation side, there's the Federal Communications Commission, the FCC. In their original Establishment Act in 1934, they were really just about communication on the ground. There wasn't really a space-based option at that point. But as satellites and communication satellites became a thing in the late 50s, early 60s, it started to come under the purview of the FCC. So they started licensing communications through satellite communications and continue to do so to this day. So any satellite that is a US-based company or has a US ground station and is communicating to anything in the United States needs an FCC license to do so. The Federal Aviation Administration, under the Department of Transportation, also gives launch licenses. So they are the ones that regulate launch and re-entry into Earth's orbit. It's launch from US shores or from a US company. Now, one thing that's interesting about the way the FAA, is authorized to do their regulation is that they authorize the launch provider. So they will authorize SpaceX, for example, the launch provider, not necessarily the individual satellites that are being launched. There is a payload review process that happens where they do look at all the different payloads on orbit. There's some things they have to do, but the license is for the provider. It's not for the payload or for the company that holds that payload or the university. And then finally, there's the Department of Commerce. And so they have an office within NOAA called the Commercial Remote Sensing Regulatory Affairs Office, and they provide remote sensing licenses. So for mostly Earth imaging, but across the spectral band. So it could be optical, but it's also, they're looking into SAR, they're looking into other ways of imaging the Earth. But there's new technology out there. There are new things happening. For example, in order to do some of these newer missions, like MEV-1 that I explained Northrop did in geostationary orbit, they needed to get a non-Earth imaging. They needed to do non-Earth imaging. And up until that time, for national security purposes in the US, there was no licenses granted if you were not going to have a camera on your satellite and it was not looking at Earth. They would not grant you a license to go out there and do it. There are companies who said, well, we want to do satellite inspection. We want to start doing servicing. We want to do these life extensions. We want to go up and be able to move a piece of debris out of the way, but we need cameras to be able to see what we're doing so that we can do it. And up until recently, and it took a number of years, there was no way to do non-Earth imaging. We call it NEI. And it took a few years for the commercial sector and the community to really work with the government to get some sort of provision and a license so that they can actually go out and do this new innovative thing. So there is a real tension right now between regulation and innovation. The regulatory framework exists, but it does not look at these new space activities necessarily, and it doesn't have the authority from Congress to go and do anything beyond remote sensing, for example, in the case of NOAA and the Office of Space Commerce. So painting that picture, I want to turn to a topic that I'm much more familiar with and much more and really interested in. I think it really touches on some very technical and policy issues that are being faced right now. So space situational awareness, for those of you who might not know, is really the idea of what objects are in space. It's looking up into space and seeing What is there? Where is it? Is it moving? So the US government, the Air Force previously, and I think it's been transferred over to the Space Force now, has a network of sensors, both radar and optical, that help create this catalog of objects. And so at the moment, I think I just told you there's about 24,000 objects in that public catalog. There are different classification levels of this. And so on the more secure classified side, there might be more objects. But space situational awareness has been happening for a while, and it's been under the purview of the DoD. And in 2017, I believe, the National Defense Authorization Act called for the service that was provided, which by the DoD, to be transferred to a civil agency. Now, the service that they were providing is if they saw that there were two objects that were about to collide, and they weren't only debris objects, that one was actually an active satellite that could potentially maneuver out of the way, they would literally, I think sometimes pick up the phone and call that owner operator and say, can you move? We have a warning saying that you're going to conjunct, or you're going to be able to soon, in 3 days, we see our models predict that you're going to hit this piece of debris. Now, those calls have been happening more and more. Those conjunction warnings have been happening more and more, just given the kind of volume and the number of satellites going up into space. And so it became clear that, a lot of these objects are commercial, and the DoD said, this isn't within our mission set. Like, not exactly not our problem, but not our problem. We want someone else to do it. We need to get a civil agency to do it. So the law was pretty unclear about which civil agency. Then, so there was a whole kind of, vetting process of who that civil agency was going to be. And during the Obama administration, it looked like it was going to go to the FAA and the Department of Transportation. And then in the last administration, it switched to the Department of Commerce. And there was written something called SPD3, Space Policy Directive 3, which directed the Department of Commerce to take the lead on civil space situational awareness and space traffic management. So space situational awareness is knowing where the things are, knowing what the objects are, and even taking it beyond that, not just what the objects are and where, or not just where they are, but how big are they? Maybe more features about them. Are they tumbling? Are they moving? All sorts of information about the objects themselves. Are they maneuverable? Are they not? Space traffic management is, people do often align it or kind of use the analogy of air traffic control, right? So we have a lot of planes. We know where they are because, there have been a lot of rules since the 1950s to come together and in some sort of interagency UN process to bring, for countries to kind of say where these airplanes are, for commercial airliners to share where they're going to be, where they're going, flight plans. And so that air traffic control system could be born out of that data, right? You need the data to do the system. Space traffic management, which the Europeans don't love that word management, so they like to call it space traffic coordination. Space traffic coordination is really that coordination of like, okay, we have two objects that are about to, maybe in 3 days, collide. Who's going to move? How are you going to move? How are you going to tell people where you're going to move? So it's a lot of that information collection, information sharing, and those rules that are maybe not legal rules, but they're kind of guidelines and rules for everybody's benefit to move out of the way. Because once you conjunct and a piece of debris is up there, past 550 kilometers, I believe, it's 25 years or 500 kilometers, it'll never come down, or it'll take years, thousands of years to come down. And so we now have an environmental orbital debris kind of issue. And so this is where the discussion is right now. Whose problem is orbital debris? Who is going to monitor and manage debris that might be happening? I don't think the US government nor anybody in the world wants to say, stop doing space, stop putting stuff in space. We already have a number of debris up there. They can be mission ending. They can collide with your spacecraft. It's a real problem. No one's going to say stop doing it. At the same time, no one wants the burden of having to either move out of the way because that costs money, fuel costs money, and people don't want the burden of having to pay for removing the debris from orbit. So it's very much akin to greenhouse gases and climate problem, or to, let's say, the kind of ozone layer issue that, we had 20, 30 years ago. We were trying to understand the effect of chlorofluorocarbons on the world, right? So one person's problem is everybody's problem. We don't always know where these pieces of debris come from. We don't know who to attribute it to. We don't know what to do about it if it happens. There are liability conventions that, there's a liability convention that was signed in 1972 on the UN. It was actually quite prescient and was forward-looking. And they say that the liability for any object that kind of might hurt another object is on the launching state. So you could be a US company, but launch from India, and India is now liable for something that happens on orbit. And that is a big, a big kind of, I wouldn't say burden, but that's a lot to think about when it comes to debris and what's going to happen if two objects are going to collide. Right now, there's a healthy discussion going on about active debris removal. So there are companies, some of you may have heard of them. Astroscale is a big one. There are other companies out there in other nations. Japan is working with Astroscale to do debris removal missions. The UK just signed on to an ESA mission or is collaborating with them, where they have also contracted with a private sector company to do a demonstration of removing a piece of debris from space. But given that the Liability Convention also says you still own that piece of debris, it belongs to the launching state, it is very complicated to go up to a Russian rocket body or a Chinese rocket body from a different country and touch it and move it, because there are all sorts of rules. And that is what I'm talking about in terms of policy solutions. You could have the best technology solution out there to remove debris, but if you cannot come up with the policy solution and work out those diplomatic issues, you're going to have a real challenge. And it doesn't even matter if you have the technology solution. So technology and policy really have to work hand in hand. I don't see a clock or a timer, but I'm going to conclude my remarks in the next few minutes, just to say that, I think that the space environment is really, really an exciting place. There's a lot happening. I will just kind of last say that on the orbital debris side, OSTP is working to create a plan, an interagency plan, to really understand what are the R&D needs, what things, for example, would the commercial sector really benefit from in terms of mitigating debris. So at the launch point, when you're launching something into space, if you want to mitigate against debris creation, what can you do? And then what are you going to do in terms of tracking and characterization? And what are we going to do in terms of active debris removal? So there is a lot of interagency discussion happening on that end. So with that, I'm going to turn it back to Sadia and Amy and see if there are any questions.
Asha, thank you so much for providing such a wonderful overview of things that are going on. We really appreciate the way that you brought together the technology and policy side of the story. So I'm going to turn things over to Amy to field any questions. So Amy, we're in your hands. So
great. We do have 3 questions right now. And Asha, so we do have a hard stop at 9:40 and it's 9:34 right now. Would you be able to go into our Whova platform and type in some answers that might not get addressed right now? Okay, great. So,
absolutely.
All right. And the voting is a little bit of a popularity contest. So the question with the most votes is, how do you expect policies for space debris to develop going forward? And I know you mentioned a little bit that no one kind of wants to be the one to have the burden of handling a lot, but do you want to say more about how you expect the policies to go?
So I'm going to answer that a little bit squirrely in a Washington way. I I know how I would like the policies to go. I would like the government to be forward thinking about it and thinking about what is going to happen if there is a major debris causing event that actually causes issues to an operating platform. I think that what I'm worried might happen is there will be some major issue, some sort of disaster, if you will, in space, and then the policy is going to follow and it's going to be very reactive. So that's how I think, if I'm going to be a realist, it might go. If I'm going to be an optimist, I would say this is our opportunity to think about how that's going to happen. At the moment, in the regulatory space, there are changes being made to the orbital debris mitigation guidelines and rules in the FCC filing. So if you want to get an FCC license, you have to adhere to a set of orbital debris mitigation standards and guidelines and practices. That is on the regulation side. I think there are a number of activities happening that are more guideline focused, like we would like you to do these things because those are best practices and good stewards of an environment. There's no enforcement mechanism on those though, right? So they're kind of good behavior, good actors, maybe some shaming that might happen if you don't do it. It's public shaming, but there's no kind of space cop out there that's going to kind of pull your license and make you leave.
Great, thank you. The next question is, how do you standardize US policies under international laws and norms when the space domain is still very much like the wild, wild west, considering countries like China, the US, and even the US have spy, anti-satellite, and even weapon capabilities, despite international treaties in place?
That's a really great question. I think that's one that the UN is grappling with right now. You know, when I was preparing for these remarks, I didn't think I had enough to say. And, you know, I have a million things to say, particularly on norms of behavior. I think one of the biggest challenges when it comes to, and it's an opportunity as well, is to kind of come up with a common language on what is a norm. The way we use the word norm is, sometimes it's normative, sometimes it's normal. Like, what is that? Is it a law? Is it a standard? Or is it the actual behavior? So we know that the law on the highway is 55 miles per hour. Do we actually drive 55 miles per hour? I don't. I usually drive 4 to 5 miles, maybe 7 miles over 55 miles per hour. So there's behavior, and then there's the law itself. I think that the UN is really the only place to have those discussions. At the same time, I think it's starting to become clear, and very recently, the UK put forth a resolution in the UN in the Committee on Disarmament, that kind of part of the UN on the first committee, which is about more security, on developing norms, developing rules, and so on responsible behaviors in space. And that got a thumbs up from the UN to say we can start a working group to talk about it. So there is some movement happening. Movement in the UN, for those of you, Sadia, you probably know, is like snail's pace, right? So it took them 11 years to get the long-term sustainability guidelines out of the UN. It's still a big win. It just takes a long time when you need hundreds of countries to sign, not hundreds, but 100 countries to sign up. So
yeah, well, thank you. I'll pass it back to Sadia right now. And if you could drop into Huva to the session, and we have a few more questions that have been asked there. So thank you.
Thank you.
Asha, thank you so much for joining us today and for your wonderful, this is a great launch to the rest of our program. So thank you for joining us. Everyone, we will be starting our next session on space design for social good. This will be moderated by Dean of Engineering, Nancy Albert, in about 5 minutes. So we will see you there. Again, Asha, thank you very much for joining us today, and we hope to have you back someday soon.
Thank you
Bye-bye.
so much. Thank you for having me. Bye-bye.